All right, so to start off our next part of Unit 1 towards our second test, I'm going to take a nice closer look at vectors. Again, we have dealt with vectors before, but now we're going to actually work with them more in depth. And again, just to go over the difference here is that a scalar is a quantity that is represented just by its magnitude only, which means a magnitude is size. And again, a quantity is anything you can count. All right, so a scalar is just something that you say, I have 5 apples, or that thing traveled 5 kilometers, or it was going 60 miles per hour. Those are all scalars. Now again, vectors, same idea, except for there's an inclusion here where you also have direction. So in our first unit there, or the first part of Unit 1, we looked at how the difference between distance and displacement, or speed and velocity, where again, distance and speed are scalars, but yet velocity and displacement are vectors because, again, you have a magnitude, size, and direction. So what we're going to do now is, again, look at vectors more in depth because we're going to use them to solve motion equations that are in 2 dimensions. So not just traveling along a straight line, they can go left and not only left and right, but maybe up and down, or say north, south, and east and west. So for example, what we're going to look at is actually just drawing a vector. So example 1, I'm going to draw the vector. Let's see here, 50 kilometers an hour. Let's see here, and our direction is going to be 30 degrees south of west. All right, so I want to draw that vector on a diagram. And so here's what I'm going to need first is what's called a compass rose. All right, so that's getting all our directions on there in terms of north, west, south, north, east. Now, what order do they go in? As most of you have probably seen before, north is always at the top, right? Where do the other ones go? Well, what I use is a little bit of a memory phrase is that I go never, and a rule I stand by in life is never enter stinky washrooms. All right. So there's my compass rose. Now I want to draw this vector here that's 50 kilometers an hour, 30 degrees south of west. All right. Now here's what this 30 degrees south of west means is that it's towards the south from the west. So actually west is our starting point, and we're moving 30 degrees towards the west. So if I draw this vector here, there it is, I just drew it in purple, the angle would be right here. So again, the last towards the, oh, sorry, I got it backwards there. Whoops, I read it wrong. Towards the south from the west. So the last letter here is where you're starting. The first letter is the one you're moving towards. So here's our 30-degree angle here. So there is my direction. And again, a vector also has direction and magnitude. And so I'm going to draw the magnitude in here is 50 kilometers an hour. I'll just put a 50 there. And there we go. And that is drawing our vector. Now, what you can do is vectors could be described 2 different ways. Now, this vector, what I could look at is that the fact that the magnitude or the size of it does not change. But what I could do is change the way I describe the direction. And how I would do that is if I know there's a 30-degree angle here, well, then our compass rose makes a series of 90-degree angles. And so, well, 30 minus 90, that is a 60-degree angle there. And so what I could do is write this direction as 60 degrees west of south. Because then this time I would be starting south and 60 degrees towards the west. All right, so there's always 2 ways to describe a vector. The magnitude will never change, but your direction will. In this case, we could look at it as starting from the west, moving towards the south, or starting from the south and moving towards the west. So that is just drawing a vector for us. Now, what we're going to have to do is tear these vectors apart because we're in two-dimensional space. All right, so we're going to take this vector and tear it apart. I'll just tell you what I mean by that. All right, so example 2 is we're going to find the vertical and horizontal components of that vector. So find the vertical and horizontal components of that vector I just drew, which is, what am I going to call it? It's a speed, or it's a velocity, or maybe it's a wind, I don't know. So I call it vector W, which is equal to 50 kilometers an hour. Again, dealing with the same vector here, 30 degrees south of west. All right, so again, I'm going to draw that vector, a nice little sketch of it here. So I draw my compass rose. So I have never enter stinky washrooms. All right, so again, I'm just going to sketch this vector in. And so again, it's 30 degrees towards the south from the west. So it's in the southwest quadrant. That's how I always draw my vectors initially. And again, it's towards the south from the west. So there's our 30-degree angle. Now, when I'm talking about horizontal and vertical components, what we're looking at in terms of our compass rose is how far left or right does this vector go and how far up or down does this vector go? Because those are the most simplest things that we can work with. We did that in our first part of Unit 1, is we just looked at things left and right, north and south, east and west. So we're going to break our vectors down into those more simpler components. And so this vector, in fact, goes left towards the west and down towards the south. So what I want to look at is this vector that moves along, that goes exactly as far left as our vector W does. And so I'm going to call that vector WH with a little h there, which means that is going to be the horizontal component of vector W. Just as my red vector here that I'm going to draw, we're going to look at how far down our vector goes. That vector is going to be called WV, the vertical component, up and down of our vector W. All right, so what we're going to do is just use trigonometry. In fact, we're going to use a lot of trigonometry today. All right, so when I'm finding my WH, and again, I should draw in here that that blue vector is vector W, which happens to have a size of 50. So again, as I said, I have a right angle triangle here because our red vector and our purple vector are at right angles to each other because they're horizontal and vertical components. They have to be at right angles to each other. All right, so what we have is a right angle triangle where I'm going to do some trigonometry. I have my 30-degree angle, and if I was to solve for WH, it is the adjacent side, and the 50 here, our vector, is our hypotenuse. And so if I have the adjacent and I have the hypotenuse, and hopefully you know trig, otherwise you're in trouble today, it would be using the cos ratio. So I'm going to have the cos of 30 degrees, cosine at cozy at home, those are the acronyms I use. So the adjacent, which is our WH, divided by our hypotenuse, which has a size of 50. All right, so again, I'm going to use my calculator here to find the cos of 30. Key thing today is make sure your calculator's in degree mode. You don't want to press all the right buttons and get all the wrong answers. So I hit cos of 30 degrees, and I get to 2 decimal places, 0.87. And that's going to equal WH over 50. All right, now, when I always have a number equaling a fraction, this is something I do. I create a fraction equaling a fraction. And you can do that by just dividing any number by 1, because anything, any number or any symbol divided by 1 is just itself. And I do that because when I have a fraction equaling a fraction, I can cross multiply and all the fractions disappear. So I have 1 times WH is equal to 0.87 times 50. Let's get a little trigonometry lesson here. Now, WH, so I take my 0.87, I times my 50, and I get 43.5. Now, I'm not done yet, because again, this is a vector. So it has to have magnitude with units and direction. So let's, because it's a vector, I'm going to throw my little symbol on there. Our units, we're talking about kilometers per hour. And what I did was my diagram here, I look at WH, and what direction is it headed in? It's going west. All right, so that is my horizontal component. I'm going to do the same thing on the other side here by finding my vertical component of my vector, the red line here. And so again, I'm going to use trig. Now from my 30-degree angle, this red line is my opposite. And again, I have my hypotenuse here. All right, so because I have my opposite, my hypotenuse, I'm going to use sine. So I have sine of 30 degrees is equal to the opposite, which is my W little v. And of course, again, my hypotenuse is 50. All right, so now out comes the calculator because I'm going to find the sine of 30. And I get 0.5. All right, again, I didn't do anything over here. So there's my WV divided by 50. Again, because I have a number equaling a fraction, I'm going to create a fraction equaling a fraction, again, so I can cross multiply. So I go 1 times WV, I get my WV. And, well, 0.5 times 50, I don't need the calculator here on that one. Half of 50 is 25. But again, I want to express that vector, because it is a vector, as such. And so I'm going to add my units in. Again, it's kilometers per hour. And I look at my original diagram here. Which way is this vector pointed? It's pointed down towards the south. And so there is my vector broken up into what's its horizontal component, where it goes 43.5 to the west, but yet 25 kilometers south. If you add them together, this is what that vector would be. All right, so those are our two vectors that if we add these two vectors together, this is the one we get. We reversed it where we took this vector and we broke it up into the two parts, which we're going to need to do. All right, so I'm going to do another one of those, breaking our vector apart. And so let's get rid of this stuff here. All right, so let's see here. We're going to find the horizontal and vertical components of a new vector. Let's see. I don't have this in my notes, so I'm just going to make one up. Let's see. I'm going to have a vector. Let's go with vector G. Well, actually, a bad one because that's gravity. I was going to do it for gates. Let's go with M. Vector M is equal to, let's go with just 70 meters. My direction, I'm going to say, is 40 degrees north of east. All right, so there's the vector, and I'm going to find the horizontal and vertical components of it. So once again, I'm going to draw a sketch. That helps me out definitely with directions and just with my trigonometry. Get my compass rose right here, so never enter stinky washrooms. All right, so now again, I'm going to draw my vector. Let's see here. It says 70 meters, so that's the magnitude, the size of it. 40 degrees north of east. All right, so I know it's in the northeast quadrant. So I'm just going to draw my vector in here. The key here is, where's that angle go, right? So again, it's 40 degrees towards the north from the east. So I'm from the east towards the north. There is my 40-degree angle. All right. Now, again, I'm going to draw my components in. Let's see here. I forget what colors I used, but here we go. The horizontal one. So we're looking at how far left or right we go, or in this, because of the way our compass rose is drawn, left and right. And so our vector here, it goes that far. And so that vector there, I'm going to call MH. The horizontal component of vector M that I just made up. I also, again, want the vertical component, the up or down. and that vector would be called MV. And one thing I forgot to put in there is my original vector here, because I want to know where the angle was. It has a size of 70. All right, so now it's time to do a little trigonometry. So again, I'll look at my MH here. And because I have my diagram drawn out, it looks like this time my horizontal component is the adjacent. All right, and again, I have the hypotenuse. That's the easy thing to remember, is that your vector is always going to be the hypotenuse. All right, so I have the adjacent, I have the hypotenuse, and so to find my MH, the size of it, I'm going to use cos. So we got cosine of 40 degrees is equal to, let's see here, again, my MH divided by 70, which is my hypotenuse. What you might notice is that I do not have a vector symbol over my MH because I'm simply finding the size of it. So that's a little bit of a notation thing. All right, so again, I make sure my calculator's in degree mode. I hit cos 40. So let's check it out here. I got cos 40. We end up with 0.77. Okay, equals MH divided by 70. All right, so then I again will do my thing where I create a fraction equaling a fraction. So I can cross multiply. 1 times MH is MH. And then I have 0.77 times 70. So I'm going to do that right now. 0.77 times 70. And I get 53.9. But as I said before, I want to make this a vector. I want to talk about this vector. So again, I'll get my units, which are meters. And this time, horizontally, I look at my arrow. Which way are we moving here? We're moving to the east. All right. Next up is my vertical component. And again, using trigonometry, I look at my MV compared to my 40-degree angle. It is the opposite. And again, I have the 70, which is my hypotenuse. So when you have the opposite in the hypotenuse, I got sine. So I've got sine of 40 degrees. Again, my opposite, MV. Ditch the vector symbol because it's got no direction. I'm just finding the size. And again, my hypotenuse there is 70. All right, sine of 40 degrees. Let's see here. 0.64. Again, to 2 decimal places. Don't round. All right, so that's our. All right, so again, here I go with my fraction equaling a fraction there. And so I cross multiply, and I've got MV, my vertical components. All right, is going to now be equal to 0.64 times 70. So let's try that out. 0.64 times 70, I get 44.8. Again, I'm writing it as a vector, and so I'm going to put units on it, of course. And my direction, let's see, check out my diagram. This vector is headed upwards because, again, they have to be drawn with an arrow, and then the next one starts from the end, and it is headed north. And there we go. So that is, again, being able to draw our vectors, figuring out what the direction is, where the angle is, and then tearing apart our vectors so you can find the left and right part, or east-west, and finding the up and down part, which is the north-south. Now, in our later lesson today at 10:30, you are going to need this skill. So I highly, highly suggest doing the homework for this day right now. Otherwise, you're in trouble at 10:30 because this is going to be our first step. We're going to take vectors apart. We're going to take 2 vectors apart, put the pieces together, and then come up with a final vector. So we're going to add 2 vectors together, again, by breaking them apart and then putting them together with similar parts. All right, so that is the start of our vectors of horizontal and vertical components. As I said, we're going